Good afternoon, everyone. Barely afternoon, I guess. We're going to go ahead and get started now. My name is Patrick Peak, and today I'm going to be talking to you about engines. And so I'm always curious to see where folks are coming at this topic from. So a quick show of hands. Who here has written their own engine? Go ahead and raise your hand. All right. Who here has used an engine written by somebody else on a project? All right, a few more hands. And who here has never heard of engines and you're at this talk to figure out what they are? All right, that's right. You guys are honest. That's great. So anyway, hopefully there'll be a little bit in this talk for everyone in all those groups. And so a couple other points. Most of the code samples that I'm using today are written for Rails 4, but not so much has changed between Rails 3.2 and Rails 4 that you can't just use these samples pretty much as they are. And hopefully I'll have time for questions at the end, and I'll be hanging out here after lunch to answer them as well. So a little about me. I'm the Chief Technology Officer for Browser Media. We're an interactive web agency in Washington, D.C., and we build websites for clients. I'm also the project lead for BrowserCMS, which is an open source content management system built on Rails, which we frequently use to build those sites. BrowserCMS, as it happens, is an engine, and engines are the exact sort of thing that make building tools like content management systems easier to do. So I want to start first with a problem. And as our friend from Dilbert here, Wally, illustrates, sometimes reuse and repeating yourself is a little too easy. When you're writing a Rails application, you're probably creating duplication. Even if your current application is completely dry, if you look at any two apps you've written, there's probably a good amount of duplication between those two apps. And as we should know, in programming, duplication is the root of all evil. And with Rails projects, we've historically had a number of ways to avoid repeating ourselves. The first option is to create a library. If you need to reuse some code, especially if it's not Rails specific, you can make a library of it and then distribute it as a gem. And this is going to be most appropriate if the code you're working with is something that doesn't have any user interface components, for example, something like an XML parser or a testing library. But what if you do want something that's Rails specific? Well, for a long time, the go-to solution was plugins. Plugins could be added directly into projects into the vendor plugins directory. And then later they were designed to be packaged as gems. But they were limited in what they could do. As of Rails 4, though, plugins as you know them are dead. And thank God, because that thing is going to start a fire pretty soon. If you have code still in your projects in your vendor plugins directory under Rails 3, it's going to pester you insistently about deleting that. So what other options do you have? Generators are another pretty common solution that folks will use. Rails has a few, and typically plugins would add some more of their own. And these feel super productive up until the point where there's a bug in your generated code. And the more generated code you have in your project, the more costly that upgrade process becomes. So for example, who here has ever used RESTful authentication on a project? Keep your hand up if you ever went back and upgraded that code to a newer version of RESTful authentication. So like 1, 2 brave souls in the room. And that's sort of the problem you illustrate with generators is once you have all this code in your application, it's yours, you own it. It's not living in a gem somewhere else that you can just update. So generators are not going to be good enough. So what to do? Now, as you may have guessed from the title of this talk, engines are our solution. And the goal for today's talk is to take a little bit of time and go through how we can better leverage these and take advantage of them. So here's the agenda that I want to cover for today. I'm going to talk about what engines are and why I care about them. We're going to walk through a sample of building an engine. We're going to talk about some interesting things you can do with engines. And finally, we're going to talk about how we can get engines to work together and how they can't really work together very well right now. So why I care about engines. I've been working with content management systems for a long time. About 2003, we started building sites for clients, and there were no open source, really viable open source CMSs available at the time. So like any eager young programmer, I figured I could knock out a CMS in a weekend, totally easy. 10 years later, I'm still working on the same project. The first version of Java, or first version of BrowserCMS was written in Java, and the problem there was that there was a really big set of limitations on reusability of components. We rewrote it in 2008 on Rails 2, and this was about the time that vendor plugins were sort of falling out of favor, so we wrote it as a gem. But we still had to monkey patch the crap out of Rails, like really deep into the internals. Like every time you upgrade Rails, the entire thing breaks type of stuff to make it work. And then in Rails 3, engines were introduced into the core for the first time. And this was really good. The upgrade to get there, as anyone who I'm sure has done a Rails 2 to Rails 3 upgrade can attest, there's a certain amount of pain to get there, but it was a nice payoff. Then when Rails 3 comes out, they did sort of a complete makeover for what engines were. And they added some really nice things that let us isolate our engines from application code, as well as take advantage of features like the asset pipeline. And the next release that we'll do, we'll upgrade to 4.0, and I'm pretty confident that this will be pretty seamless because most of the stuff now that we have is dependent on these engine APIs, which are stable public APIs. So what are engines? The short answer is it's a bit like a mini Rails application that you can add to other applications. Because it's packaged as a gem, you can easily reuse engines between projects. The longer answer is, suppose you have this giant, massive Rails application, and I'm sure nobody other than me has one of those right now. So you've got the business domain, which is nominally what your client is paying you to build, but you've got a bunch of other stuff in there too, like maybe you're selling stuff, maybe you're managing users, maybe you're doing some blogging. And some or all of those things might be useful on a second project. And what you don't want to be doing is copying that blogging code out of your first app into your second app just so that you don't have to rewrite it. Well, with using engines, we can actually split this behavior of this massive app into a bunch of separate gems. Instead of this one massive app, we can have a smaller, focused app which concentrates on the business domain, and then just have it depend on and configure these external engines. And then when we have another app, and we want blogging, we can just have it also use those. So let's look at some examples. Here's some popular engines that folks may be familiar with that kind of showcase what you can do with these tools. The first is Spree. Spree is an e-commerce / shopping cart solution that is built as an engine. It kind of does all the standard stuff that you would expect out of a store, like products and order management. I don't personally have much experience with it, but the Spree guys are actually primarily based out of DC. We actually shared an office floor with them at one point, so I kind of know who to go to pester if I have questions about stuff. Another popular engine folks are probably familiar with is Devise. It's probably the most popular authentication solution for Rails right now. It provides a flexible way to handle user management and authentication. It's really pluggable. You can handle everything from email confirmation to remember me functionality. Another common use for engines is general purpose admin dashboards like Rails admin, which is pictured here. These do general discovery around the models in your application and then generate a sort of stock UI and dashboard for them, which allows you to just sort of manage them. And these can be a nice low-cost way to get started on an admin area of a site, somewhat akin to how other frameworks like Django, which comes from the Python community, give you this sort of auto-generated management interface. And you kind of abandon them over time, but it gives you a quick way to get started. So let's talk about building an engine. We're going to work through an example of how you can create your own engine and then show off some of the interesting things you can do within an engine. And suppose you decide what the world really needs is another content management system. It probably doesn't, but we'll use that for an example. And to make it easier for other developers to add this to their projects, we're going to build it as an engine. And also because I'm super original with my project names, we're going to call it RubyPress. So here is the command to generate a new mountable engine. And yes, I know that command is called plugin, and you may have heard somewhere that plugins are dead, but just trust me, that's what the command is actually called. A quick digression, there are actually two sorts of engines. There's full and mountable. I'm not really going to cover, for the purposes of today's discussion, full engines. They're very, very similar to mountable engines, the difference being they don't namespace things. So I think they're kind of a bad idea if you're going to distribute your gems to other folks. But I'm happy to talk about that after the talk. So anyway, we run this command, and we get this pile of code, very similar to what you get when you create a new Rails application. A couple key points. You're going to get a gem spec, again, because we're going to be distributing this as a gem. We're going to get an app directory, just like we would for any Rails application. And we're going to get a dummy Rails application, which is going to be put in the test directory, which is automatically set up to use our engine. And the key takeaway from this is that engines actually can't live on their own. They need a Rails application to like host and test them. So the plugin command will generate that into your engine for you. And so any content management system, we need a way to manage pages. So we're going to add a resource to our engine. And so here we're using the Rails generator command to give it a few fields. I'm using the Rails 3.2 shorthand to make name, path, and content implicitly as strings. So hopefully that will allow folks to actually see the stuff on the slide in the back of the room. And so this is what you might expect to see if you were to take a look at this controller file that was just generated. And indeed, in a normal Rails application, this is exactly what you would see. But because we're working with a Mountable engine, you get something slightly different. There's sort of two changes that you can see up there. One is that the controller has actually been placed in a subdirectory called RubyPress, and the controller itself is in a namespaced module also called RubyPress. And so why is that? Well, because we created a Mountable engine, all of this stuff gets isolated under a namespace. What we're looking at here is the engine.rb file, which is actually the sort of central configuration point for engines. In this case, because we created the engine called RubyPress, all of our classes are going to get put into that namespace. It's also going to do a bunch of other stuff for us, like making our routes and generators automatically add that namespace to any of the files we generate. Next up, let's talk about routing. Since engines have their own controllers, you might be wondering how I avoid conflicting. Your app's routes are going to avoid conflicting with the engine's routes. You can very easily imagine a solution where you've got your app and then 2 or 3 other engines, each with their own routes. And Rails solves this conflict by essentially having the engine be its own sort of bucket of controllers. So routes from one engine don't mix in with each other or the main application. Here's the routes file from within our engine project. It's very similar to your project's routes file, with the exception of what object is actually holding the routes. In this case, we're adding them to the engine class. What you don't see is this. This is what you would do in your application. You would add the routes to the application object. So how would we access our newly defined controller? Here's the UI for our application. And in case you're wondering, yes, thank you, I did do the design for this myself. And so assuming we add a little bit of the standard CRUD behavior to our pages controller, we would access the index action by going to that URL up at the top. And the key thing to note is that we've nested this, there's this /RubyPress in the URL. And so where does that actually come from? Because we haven't specified that anywhere in our project so far. Well, the answer is in the application itself. What you're looking at here is the application routes file. And you can see that we add the engine using this mount method and then give it the path that we want the engine to be mounted at. You can also see that we have this second root URL, or root route defined here. And the key takeaway here is each engine and the application can each have their own separate route that's available. So once the routes have been defined, let's take a look at how you would actually link to them. Both the engine and the main application have their own helper, which holds essentially a collection to the routes for that engine. So up at the top, you see we've got main app. That's how you get a reference to routes from your main application. In this case, we're getting the root URL for our main app, which resolves to just a /. And then if you want to access the engine's routes, you use this RubyPress helper. And in the middle example, we're accessing the root URL, which again is /RubyPress. And then the bottom example is how you would do the sort of standard CRUD access. And in this case, we're passing a page object to this pages path in our RubyPress engine, and that knows how to access it. And this is fine, but prefixing all of our routes seems like a little bit of a horrible pain. We don't want to have to do that everywhere. And thankfully, we can be smarter about this. Rails can implicitly figure out which set of routes you want, either the application or the engine, based on which file you're in. And anyone want to take odds that this is the actual new secret prototype that Apple's going to reveal shortly? Called the iShoe. Tweets as you walk or something like that. Here we are in the layouts file from our engine. What we're trying to do here is create a menu where we're accessing a set of routes, some from the main application, some from the engine. But since we're in the engine itself, we don't need to prefix any of the engine routes. So new page path and page path, no helper needed. But if we want to access the main application, we have to use the main app. Flipping this around, this is a view from the application itself. Again, our application routes don't need a prefix, but we do need them if we want to access the RubyPress paths. So one question you might have is, where does that RubyPress helper method come from? True to its configuration or convention over configuration roots, Rails will automatically generate this for you based on the name of your engine. But if you want to change this for whatever reason, you can do so in two places. The first is by editing your project routes file here. We have specified the name of the engine as admin, and so that would be used throughout instead of the RubyPress. The other place you can specify it is in the engine itself, where you can change the default name of the engine using this method here. Next up, let's talk about migrations. This is one of the really nice additions that was added in Rails 3.1, because the way you did this was really sort of non-standard prior to that. This is actually the migration file from the resource that we generated earlier. We can see the namespacing showing up again in two places. One is in the name of the file. In this case, while we called it pages, we get a file called create RubyPress pages. And then we also get a table called RubyPress_pages. And the nice thing about this is that the engine is essentially going to namespace all of your tables that you create, which reduces the chance of conflicts when this migration gets put into your project. Since this migration is stored in the gem, the next step is to get it out of the gem into your project. And the engines will make a rake task available like this automatically. And when you invoke this, what's going to happen is it's going to copy every file in your DB migration in your engine into the project that you're at. But it won't overwrite migrations that are already there with the same name. And this makes it nice when you need to upgrade and release a new version of your engine. Users can just rerun the same task, get only the new migrations, and not worry about breaking the old stuff. So after you run the previous command, this is the name of the migration file that you're going to get. And on the right, where I've got the pounds, that timestamp is actually going to be set to like right now when you add it to your application. And that preserves the order of your migrations and how the database was changed. The other thing that happens is it suffixes the name of the engine on the file. So it's create RubyPress pages.rubypress. And that's going to be nice because you're going to have an easy way to scan through and see, OK, these are the migrations and what engines are these things coming from. Now, if you have a number of engines and you want to get all the migrations all at once, there's also this rake task, which is just going to copy everything all across, which is good if you want to like set up a bunch of engines all at once and then just install them. Next up, let's talk about configuration. In a typical Rails application, you might find yourself doing configuration in either the project's environment file or in an initializer. And with an engine, you have a lot of the same behavior available to you, but you can sort of pre-generate this stuff. And ideally, in a well-designed gem, a user should be able to just require that gem in their project and then only need to change stuff or add additional configuration if they don't like the defaults. So let's look at some of the ways we can configure engines. The first thing to recognize is that most of the standard Rails application configuration behavior is available to you from within an engine. The engine.rb file is very, very analogous to what you can do in an application.rb file. So to some extent, you just may want to look at this guide, which is the Rails configuration guide, and then just kind of go and play and see what you can do, because there's a million options. But I did want to look at a couple of concrete examples of things you can do with your engine. The first one you might find yourself doing is adding initializers. Engines can define their own initializers, which hook into the Rails boot up sequence. Rails defines a series of hooks, which you can see here is the action dispatch prepare dispatcher that happen during startup. And we can specify the initializers such that they happen after the objects we need have already been required and booted up by Rails. In this case, what we want to do is we're going to add some additional DSL to the router. And so we're adding a module to the routing mapper, but we're doing it after we know that class has been set up for us. Here's the new behavior that we've defined. So in our engine project, we're adding a new method called useRubyPress, which does two things. It's mounting the RubyPress engine at a reasonable default, and then it's adding this second route for just /help. And one thing to note here is that you do have to namespace the controller name here, because this method is going to get invoked within the context of your application routes file. And so here's how we use this. And so this is a little bit of a trivial example just to show what you can do. Here we're just making it a little easier, shorter to add it to our project. But you can use this same technique to sort of extend or augment any of the core Rails pieces, active record, active controller, et cetera. That's because most of the core parts of Rails now are all rail ties. And rail ties are actually the superclass to engines, and they define very much how all the configuration of this stuff fits together. Another option that you have is middleware. Engines can define their own middleware. In this case, we're configuring rack cache, because we're a CMS, we want to be fast, we want to cache pages. So we're setting up this middleware piece that's automatically going to be included. So any routes that get passed to our engine are going to get passed through this middleware stack. And that's because engines are actually their own rack endpoint, as well as a lot of other things. So they can have their own stack and do whatever they want to do within there. We can also use engines to pre-configure the generators that our projects use. For example, here we want RSpec files to be used everywhere instead of a test unit whenever we run generators. And so just by requiring this gem, this changes the project defaults that are available. Now, apart from all the fun to be had by imposing coding standards at work, you can use this to make a sort of convenient configuration setup for a project. You just want all these defaults. You just want to add this engine. You don't want to configure a bunch of stuff. And so you can build a little engine that just does this default behavior. Or if you're writing your own test framework, although please, 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 please don't do that. We have a few of those already. You could use a technique like this to make that automatically the correct generator for a project using your engine. A great way to make your engine more usable is to provide options for configuration, right? So you have your sort of idea of how you want to do things, but when folks add it to their project, they're going to want to make some changes. And so there's a million ways to do this, but I think we can all agree one thing is that when you provide configuration options, you need to provide reasonable defaults to go with them. And here's how we can do that with engines. The approach that I'm taking here is to sort of use the sort of central configuration mechanism that you get with application.rb in your environment files, rather than using an external format like YAML or in an initializer. And the reason for that is this is pretty easy to set up in the project. This is all the code you need. And you also find this very familiar with, developers are going to be very familiar with this. In addition, we can take advantage of this by specifying different values in our project in different environment files. So what we're doing here, first off, is we're creating our own configuration namespace, in this case, the .rubypress as in ordered options. And then we're setting up a reasonable default in this before configuration block in our engine. And what this does is, this is our default, but if anyone adds this to their project, they can override this value. Here we're creating a site name attribute, and this might get used by our CMS to stick into titles or headers, stuff like that. And so now that we have this site name attribute, we can override it in our project. In this case, we're doing it in the production RB file. Maybe we need a different name locally. So that's an easy way to set up configuration and make your engine easier to set up and change for your users. So now that we have our engine created, how do we actually get people to use it? Well, the best way to facilitate that is to actually make it pretty easy for new users to get started. At a bare minimum, write some documentation that tells users, where do I get started? How do I use this thing? Update the README file that Rails generates for you anyway to contain something useful for your users rather than just the default stuff that it comes with. GitHub is going to plaster the README all over the front page of your project anyway, so it's a good place that folks will go to start looking. Where I like to start is documenting the exact steps that you need to take in order to install the project. In this case, what we've built so far, there's 5 steps that we need to do. We need to add the gem to the gem file. We need to run bundle install. We need to add the migration to the project, run the migrations, and finally mount the engine. And what we learn is by just writing down these steps, we know there's too many of them. And this is ideally where we would like to get to. This is what I want my install script to look like. I just want to be able to add the gem and then run some sort of installer that does all the rest of that stuff for me. And we can simplify the installation by taking advantage of the fact that engines allow us to bundle generators into the engine. And this can be used for pretty neat things like installers. And this is the code that you would need to do to make the previous slide happen. Essentially, we just took the installation instructions and then built them as a generator. Now, it's debatable whether you want to actually run db migrate from inside the installer. But again, for the purposes of demo, I just want to show you the power of what you can do with an installer like this. So let's talk about the asset pipeline. One of the major additions in Rails 3.1, apart from engines and the new version of that, was the asset pipeline. And I think folks are more familiar with this these days, but for those that aren't, the asset pipeline is basically a framework that allows you to organize and compress JavaScript, HTML, images, et cetera. More importantly, for our purposes, we finally have a means of packaging Vue-related code that's not ERB into the engine in a way that makes sense. So prior to 3.1, dealing with this was very tedious. Suppose, for example, you have a gem that contains a bunch of complicated JavaScript code, images, CSS, et cetera. A good example of that would be something like CKEditor, which is an open source WYSIWYG editor. Again, it's got a pile of JavaScript and HTML. So if you had an engine that needed to use that, you would basically have to have those files in your gem, and then you would have to write a rake task that essentially copies all those files out of that gem into the public directory of your project. And that's OK up until you need to make changes to any of those files, or you need to update the project later. And then now it's your responsibility to go through and merge and diff and figure out what's new and what's old. So with the asset pipeline, engines can actually focus entirely on providing and packaging all these Vue-related code in the engine itself. A good example of this is the CKEditor Rails gem. This is an engine that is essentially just HTML, JavaScript, and CSS. There's no real Ruby code in there. And very much like how the jQuery Rails gem is. And the nice thing about this is when you want to use these, there's no copying, there's no duplicating or diffing of files when you need to upgrade from 3.6 to 3.7. So hopefully we'll get more engines of this type. I like this as a pattern to have these sort of pure front-end engines that you can then just reuse in multiple ways. This makes it really easy for one engine to be, OK, this is my Vue code, and I could have 2 different competing augmentations of how I want to use this gem on top of it. And so one of my favorite things is to delete code. So when the asset pipeline was introduced, this was a great day for me, because I got to go through and delete a couple hundred files from the BrowserCMS project and replace them with one line in the gem file requiring that gem, and then another in the application.js pointing to the right version of the CKEditor. So let's talk about how engines can and can't work together. There's a number of challenges here. There's some good stuff and some bad stuff. But overall, I think because engines are such a new concept that we haven't really figured out really good patterns on how to work this. So the easiest sort of use case is where you have a set of engines that are very explicitly designed to work together. For example, let's say I have a website. I want to use BrowserCMS, but I also want to have additional behavior as well with other engines like news or blogging. In this case, though, these other engines have been very specifically designed to work with BrowserCMS. I can't just take a news engine from, say, Radiant and drop it into my project, or vice versa. With a common stack, you can establish a number of conventions that each related engine will follow. One of the advantages of this is you get a streamlined experience for both the developers as well as the users. For example, one convention we follow with BrowserCMS is that all engines define an installer so that we can run this one script to just add, with a single line, add this engine to our project. And this is the code for it. It's pretty simple. Basically, the installer in the core project just requires the gem and then delegates to an installer in the other engine. The other benefit of a coordinated approach like this is that you can have sort of common UI idioms that all of the engines share. And so one of the great hopes for engines was that we would create this ecosystem where multiple engines could be just sort of plug and played into your project in any sort of Rails app. And so I have a Rails app, and I want Spree, and I want Rails admin, and I want the engine that you guys are going to write, and I want to put those all together. Well, unfortunately, there are some challenges to making this work correctly, and they sort of boil down to these 3 points. One is that we have the issue of incompatible dependencies. Another is that Rails doesn't really have a common security model. And finally, engines will often have mismatched user interface. We'll talk first about the incompatible dependencies. So let's say we have 2 engines that we want to add, Spree and Rails admin. And Spree has a dependency on one version of Devise, and Rails admin has another incompatible dependency. Well, when you try to add these to your project, Bundler is just going to reject them and say, nope, sorry, not going to happen. And at this point, you have to either go fork the gems and play with their gem spec, or you just can't use one of the other engines. And so if you're writing an engine, you can make this a better world by looking at these steps right here. First off, minimize your dependencies when you're writing an engine. The less dependencies you have, the less likely they're going to conflict when folks add your engine to their project. Use rational versioning. This is actually something that is well documented in the RubyGems docs. It's this sort of major-minor build syntax, 354, where major is backwards incompatible, minor is backwards compatible, adds new features, and then builds are backwards compatible but have implementation details. And the nice thing about this is if you follow it, it makes it really easy for us to use the tilde greater than anywhere you need to. And finally, the robustness principle. In your engine, be as liberal as you can be in what you accept as a dependency. It's much better to be dependent on tilde greater than 2.0 versus 2.00, right? So a new point release of Rails comes out, and you don't have to release a new version of your gem just so users can get the latest Rails security patch. Which I'm sure there's one due any minute. The second issue is there's no common security model with Rails. So to be useful to anybody, any non-trivial engine really is going to need some sort of security. For BrowserCMS, we're using RESTful authentication. Spree, as I understand it, is opinionated towards Devise. And sort of one of the few agreed upon conventions we have is this use of the current user method in our controllers and views. But each authentication project has their own idea of what a current user might be. So a quick recap of 2 terms before we go any further. The first is authentication. Basically, the idea here is that who are you and can you prove that to me? And the second is authorization. Once I know who you are, what are you allowed to do? And so the Rails landscape for these type of solutions is, let's just call it fragmented to be charitable. These are screenshots from Ruby Toolbox, which is a site that tracks the popularity of various projects, Ruby projects. And I checked last week, they list 15 authentication projects, which is 5 more than the last time I gave this talk last year, and 21 authorization projects, which is 4 more than the last time I gave this talk. So a quick survey of the room. Raise your hand if you're using Devise on a project now. All right. Raise your hand if you're using OmniAuth. Okay. Raise your hand if you've written your own custom authentication solution. All right. So therein lies the problem. How do you expect me to write an engine that plugs into your security? We can't even get this room to agree on one solution, much less the entire community at large. And I don't think there's any real silver bullet here. To be honest, but I think we as a community might want to work towards having some sort of least common denominator for security, much like we do for rack is for web servers. And then the third point is mismatched user interfaces. Frequently, engines will have their own user interfaces. And it's pretty unlikely that you can just take 2 user interfaces and then smush them together and have them just work automatically. And they're not necessarily going to make sense unless they were specifically designed to do so. For example, here are 2 screenshots from Active Admin and Rails Admin, both of which are doing nominally the same thing, but they have sort of very different, slightly different takes on it. And this has the least obvious solution in my mind. Really, they boil down to you can either design your engines so they have no UIs, but then you put the burden on the developers using your engine to provide and build a UI based on your APIs. Or you can kind of accept a single UI paradigm. And this is something that like a CMS project can get away with because they sort of all plug into the sort of master UI. So to recap, what I hope you have learned from today's talk. First off, engines are the future, and they are awesome. Almost as awesome, I dare say, as a stormtrooper with a time machine. Engines can reduce errors from duplication. This picture is actually taken in the 1800s, but I'm pretty sure there's a failure to unit test somewhere behind this story. And when done right, engines make code reuse easy. And that's the end.